Okay, so we're going to get started with, if I were to say, okay. No, I'd like to start, but okay. All right. So, if I had to say what the most important thing we're going to do in algebra this year, or maybe not the most important, but the thing that you will need to use the most in the future, what we're going to start talking about today is that thing. So the big idea of factoring that we've been working on for like a couple weeks now is going to transform into quadratic trinomial factoring, which is probably the thing, again, that you will see the most as you move into Algebra 2, pre-calculus, calculus, etc. This is what you will use the most. So we started by looking at just finding a GCF in general, and then we looked last week about factoring out a GCF, which is what was in your rewind. So can somebody teach me, I guess, how you do the problems in the rewind? Diego. Oh, well, good timing anyway. How would you do it?
I would do it, okay, so number one, right?
Mm-hmm.
Okay, so basically what would you do? You'd see if you could, if any of the two, how do you say it?
Terms?
Yeah.
Yeah.
Okay. If they have anything in common.
Good.
C, but they're
Coefficients?
coefficients.
Mm-hmm.
Don't quite.
Yeah, okay, so your only GCF there would be C, right? So then Diego says, so you find C, and C is called your what then? Take the pressure off, Diego. What is C called? GCF, right? So we're factoring out the GCF of C, and then what goes inside the parentheses?
8C plus 7.
Where did 8C come from? It had a 2, but now it doesn't. Why? Yeah, you factored 1 out, so you only have 1 left here, and then in the 7, you factored that C out, so you have nothing left there. Perfect. Okay, so ultimately, our goal when we're factoring is essentially to take our exponents and lower them, right? So we took something, and again, it might look a little more complicated, but now we have a lower exponent, so now we're going to be able to solve this in a way that we couldn't have before, okay? Because we don't have an exponent of squared, or down here we made our smaller exponents a number 5, we lowered 1 to the exponent of 5. So the whole goal, again, with factoring is even if it makes it look a little more complicated, we're lowering our exponents so that ultimately we'll be able to factor them. So what we're going to talk about today is how we can use integer multiplication and addition, which is just a fancy way of saying multiplying positive and negative numbers, and to find binomial factors of quadratic trinomials. Again, this looks complicated. A quadratic trinomial means that it has how many terms? A quadratic trinomial has 3 terms, and it goes to what power? Nope. Quadratic goes to the, nope, that's quartic. Second, goes to the second power. So quadratic's a tricky one because it sounds like it should go to the 4th power, but it's to the 2nd power. So a quadratic trinomial is probably the most common thing that you're going to factor. So for example, we looked at things like this. We looked at things like x squared plus 6x plus 12, or something like that, right? And that's a quadratic trinomial because it has 3 terms and it goes to the 2nd power. But let's take a look at this one right here. So what could I factor this into? What could I factor into here?
2.
I would factor out a 2 and an x, right? Because they all have x's. So I would look at that like 2x, and then what would that give me?
4.
Put it away.
You can go x to the 2nd power.
I can't go x to the 2nd power because this one doesn't have an x to the 2nd, so I couldn't factor that out. So this would give me 4 what? 2. Okay. Good. Okay, so the x's all decreased by 1. So now we have a factor of a monomial out here, our GCF. And then inside here we have a quadratic trinomial because it's 1, 2, 3 terms with a power of 2. So that's a quadratic trinomial. So what we're going to do today is we're going to figure out how to factor this. So every standard quadratic trinomial is 3 terms with a degree of 2. In other words, it looks like this. ax squared plus bx plus c, where a, b, and c stand for any numbers. So those are just constants. But this is the form that it should be in. What do you notice about the order? The x is decreased. It starts with the 2, then the 1, and then the one without an x. So we call that c as our constant. All right, so every standard trinomial should be written in that order. If it isn't written in that order, you should change it so that it is. So if that means you have a negative on the first one, that's fine, but you need it in this order where it's got x squared, bx, and c. Okay, so let's remember, how do we do this? How do we could do the box, or you can just distribute, right? Either one is fine. So we'll set up a box here. And what would that give us? What would be in this box? And in this box? And this box? And this box. So then the answer would ultimately be what? X squared 10x, where'd that come from? 6 plus 4 is 10x plus 24. All right, remember that when you do the box method, the best part about it is that your common terms are typically diagonal. So you remember you add those together once they're in the box. Okay, so when you multiply two binomials, what does it end up giving you? Usually a trinomial. When you multiply two binomials, it gives you a trinomial. So what we're talking about today is how to go backwards. If I give you this right here, how can you figure out what this is, what your two binomial factors are? Because remember, factoring is breaking it down into the multiplication, so we're going backwards. How do you take this trinomial and figure out what binomials you needed to multiply to give you this? Okay? So, how would I do that? Here's my standard quadratic trinomial. So I give you this. I say, factor this, x squared plus 6x plus 9. How do you think you would do it? Well, you know to get the x squared, where does that come from? What gives you x squared? X times x, right? So you need two x's. So you write your basic binomial, because you know it's going to be a binomial times a binomial. And the first one should be x times x. How do you fill in this one? How do you figure out what goes here? I'm going to go back. Take a look at this. Take a look at this answer and this multiplication problem. How could you figure out what's going to fill in this box and this box right there? What do you mean when you add it? Okay, so what do these two things do? They add up to 10, right? So they add up to this one. Uh-huh. Good. And so they add to that and they multiply to give you this. So you're looking for something that, again, if we're calling this A, B, and C, you're looking for two numbers that multiply to C but add up to B. Okay? So that's going to be like the phrase that I'm going to repeat all the time. Multiply to C and add up to B. You can flip it. Add to B, multiply to C, whatever you want to say. So that's what we're looking for here. We're looking for something that's going to multiply to this but add up to this. And we know that this has to be x and x, because that gives me x squared, right? So that can't be anything else. There's nothing else you could multiply that would give you x and x, except for x squared and 1, but don't even worry about that. So that one's going to be x and x. So what could you multiply to give you 9 that would add up to 6? 3 and, perfect. So then this is 3 and this is 3. How would you check to see if that's right? Do the box, do the distribution. I'm going to distribute this time. So I'm just going to draw my 4 arrows. What's x times x? What's x times 3? What's 3 times x? And what's 3 times 3? All right, and then I combine 3x plus 3x, which gives me... So did that give me the right answer? Yes. So this right here is your answer. You just factored a trinomial. All right? So factoring trinomials means figuring out what two binomials would multiply to give you that answer. So this isn't your answer, this is just you doing what? Checking your work. Yeah, plugging it back in and checking your work. This right here is your answer. Okay, so here's another one. Here's another example. I'm going to put this on a blank page and we're going to look at it. All right. This one's much larger numbers, right? So we don't do it any differently. What's my b? So I need it to add up to 19, right? And I need it to do what to 60? Okay, my binomials, I'm just going to write two blank binomials. And I know what has to go here and here. This has to be x and x, because for now, there's nothing in front of here. It's always going to be 1 today. All right, so this is going to be easier today because this is always just going to be x and x. So now we just have to figure out what can you multiply to get you 60. So what are some things you can multiply to give you 60? Let's make a list. So what could you multiply to get 60? 1 times 60, 2 times 30. What else? 10 times 6, 12 times 5. 3 times 20. Does 4 go into 60?
Yeah. Wait, 5 times 4.
We have that, yeah. 4 times what?
13, 14,
15. Okay, I think that's it. 5, 6, 8, 9, 10. I think that's it. So then do any of those add up to 19? Yeah, which one? 4 and 15. So then what goes here? And this one, 15. And because it's positive, they're both positive. All right, since this is also positive. So you need a positive 4 plus positive 15 gives you 19. So how would we check that? So this would be x squared, this would be, and this would be 60, right? And then when I put that together, x squared, what's 4 plus 15? What's 60? So is that right? Yes. Okay, so you can do this, which is guess and check. You can plug in a bunch of random stuff and do all the math to figure it out. I think this tends to be an easier way to do it. Make a list of your factors, and then you're looking for the one that adds up to b. So remember, adds to b and multiplies to c. All right, so you want it to multiply to give you this last term, but to add up to this middle term. Okay, it's always going to factor to what? To what? Yeah, the x and the x at the beginning, but you're always, before you even start, you should write these, because what are these two things? 2 multiplying 2 binomials. So it's always going to look at like 2 basic binomials. So let's do one more. So try this one. All right, so try that one at your seats. Good, don't forget your parentheses. Good. Yeah, you're supposed to write down the answer. So you're looking for the one, something that adds up to this, but multiplies to this. So I always start with the multiplication because there's like less of them. So what could you multiply to give you 30? 3 times 10. Are either of those going to give you 11? If you add them up? 5 and 6, right? So then it would be x plus 5, x plus 6. Is that what you got? Okay. Yes, I think that's right. Perfect. Okay, guys, what are our factor pairs for 30? 1 times 30.
5 times 6.
I think those are all of them, right? Which one also adds up to 11? Okay, 5 and 6. So it's going to be x plus 5, x plus 6.
Will it always like add to the,
Ah, what do you mean?
will it always add up to 11?
Yes.
So there's always a definite answer.
If it's not prime. If you can't do it, it's prime, but hold that thought for just a second. Okay, do you need to make this list every time?
No.
If you saw it in your head, do you need to make that list? No, I'm never going to ask you to do it. If you are at a loss and have no idea what to do, I would start by doing this. But remember, the goal is multiply to this one and add up to this one. And the reason I always start with the factor pairs of 30 rather than saying what can add up to 11 is because there's a lot more things that can add up to 11 than can multiply to 30. So it's just a smaller list. Okay, now Brendan's question was good, and I want to look at this because all of these so far have had a plus sign right here. But what if they don't? What if it had a minus sign? What would the difference be? What do you think, Brendan?
You have to find which two. You have to turn it negative. Or turn
Okay,
it
you need a negative somewhere, right? Where? Yeah.
Instead of writing it out like that, like x plus 8 and then x plus 80, could you just do x plus 80 and then parentheses instead of parentheses put x squared?
If they were the same, yeah. Okay. So what's the difference here? It still is a standard quadratic trinomial, right? So that means I'm still going to factor it into two what? Two binomials. These are still going to be what? X and x. The difference is that I need to multiply to a what? Negative 15, which means one of my numbers needs to be what? Negative. One of them has to be negative. So I need something that's going to add up to 2 that multiplies to 15. So what are my options with 15? I think that's it, right? So then I'm looking for one that's going to add up to 2, except one of these has to be what? One of them has to be negative. So really here I'm looking for one that is going to do what? Subtract to 2. So because this is a subtraction sign, now I'm looking for one that's going to subtract. So which one would subtract to 2? Okay. So I need this one. And then I need it to be a positive 2, which means which one should be positive? 5. So it's going to be x plus 5, x minus 3.
do you put the x2 on the outside?
There's no x2 on the outside. Because you're not factoring out a GCF here.
What happens to the 2x minus 15?
What? Sorry.
What happens to the 2x minus 15?
What do you mean?
Or is it still part of it?
It's still part of it, because think about, like, what would you do to solve this? You'd multiply it, like, using the box, right? So you do x times x, 5 times x, negative 3 times x, and then, so that would give it to you. Because if I distribute this, I get x squared plus 5x minus 3x minus 15, which ends up giving me my answer. It's exactly working backwards. It's, I'm giving you the answer, you tell me what the question was. Okay? And there's a reason for this. There's like a reason we're doing all this. But, okay, so down here, what am I looking for? Something that adds up to 6 and multiplies to 16. But because it's a negative 16, then am I really looking up for what adds to 6 or what subtracts to 6? Okay, so my factors of 16 are 1 and 16, 2 and 8. Do I need to keep going? 4. All right, which one is going to be my answer? 2 and 8, because that'll subtract. So this always, how do I start? X and X, right? Now, I need to be a positive 6. So then which of these should be positive? The 8, because you want the bigger one to be positive, so this is positive. And then this would be minus 2. Perfect. You guys are doing great. Okay, so you're just working backwards. You're just trying to figure out what it is. If this is positive, then both of your answers are either going to be positive or negative. Okay? So what happens if you have this? Someone give me a number between 1 and 10. Okay. I think this will work. All right. So what's happening in this one? The signs are what? They're different? Because the 6 is positive, right? But the 5 is negative. So I'm still going to have what as my first one? X and X is still going to be my first one. Now I need a positive 6. So what gives you a positive when you're multiplying? 2 positives or 2 negatives? Since this is a negative, what am I going to need here? 2 negatives. And then somebody said it. Negative 2 and 3. Why? Negative times a negative gives you a positive 6, but negative 2 plus negative 3 gives you a negative 5. Okay? So you can try to memorize like what the signs will be in different instances, but honestly, the best way to do it is to just say what multiplies to this, but adds up to this. Because negative 2 plus negative 3 gives you negative 5. So I wouldn't try to do like any gimmicky multiplication or memorization of crazy rules. I would just try to remember multiplies to C and adds up to B. Okay? Okay, questions on these? Honestly, there really is no better way to do these than just to practice. So we're going to do some practice right now. All right, so try all of them. But if you don't have time, I will let you know when to cut off so you have time for your exit ticket.